Hello and welcome to the Countering Climate Skepticism podcast. Have you ever felt frustrated by the disinterest people seem to have in climate change? Have you ever encountered people that downplay the seriousness of climate change, either online or in person? Have you heard people say, it's natural, or climate change has always happened, right? Like some kind of climate denying Alan Partridge or something. If you're anything like me, this can make you feel pretty helpless and demoralized. So this podcast is our attempt to help address this problem. We aim to provide the counter arguments in the common climate skeptics playbook and give you the basic knowledge to counter the oh so pervasive bollocks of climate skepticism. My name is John, a history teacher, and with me is my co-host Mark, a climate researcher. How are you doing, Mark?
Not too bad, John. Very pleased to be here with my Corona beer already half drunk.
Nice.
How the devil are you?
I'm very good, thanks, mate. Very good. Just got back from a festival a few days ago, so feeling a little bit worse for wear. Like can't do festivals like I used to when I was younger.
Yes. What sort of festival was it?
It was some brutal death metal, as is standard for me. Yeah. You know, throwing down in the mosh pit and listening to some really heavy tunes.
Nice.
But you know, like metalheads are nice people, really. They just like songs about death. Cool. Okay, so we're this episode we're actually re-recording part of it because we messed it up the first time, and so you're getting the vastly improved version. Well, I'll leave you to make the decision on that. We re-recorded it because we were waffling on a little bit. So if you want to listen to that version, I'm sure we can release the waffle full version at some point. In today's episode, we're going to be making some brief introductions as to who we are before we address the first climate skepticism argument regarding the pitiful amount of carbon dioxide in our atmosphere. If you're here just for that and you want to skip all of our nonsense chatting, then we'll put the timestamps in the show notes and you can skip ahead. But let's get on to our introductions then. So Mark, tell us a bit about yourself.
Cheers, John. Yeah, so I've basically had spent the last 10 years in university studying climate-related things. Nice. So I started off with an undergraduate degree in climate science at the University of East Anglia in Norwich, UK. Cool. And then after that, I then continued on at the same university with a master's in climate change. So a little bit different, but obviously the same ballpark. And then I moved to the University of Reading in the UK, where I'm doing a PhD on atmospheric turbulence and its relationship to climate change. And I'm in the last year of that now. So it's pretty busy, but yeah, it's fun. And so basically, I think I should know something about this subject.
Yeah, absolutely. You know, if there was any doubts about our qualifications for being able to talk about this, well, you know, Mark definitely is the expert on this and knows what he's talking about. For me, I'm a history teacher. I've been a history teacher for 15 years. Apart from the last 12 months when my wife and I we went traveling, went around Europe for 6 months, went around America for 6 months. Traveling and touring the world. So yeah, like I'm here really as the person who has an interest in climate change, has seen its impacts across the world as we've been cruising around the States and things like that. But really just want to know more about it, want to find out more about it, and Mark's here to enlighten me. I guess on to next then Mark. So do you want to tell us a little bit about how this podcast came about?
Yeah, sure. So basically, on a whim, I decided I would like to contact our old English teacher, and so I found him on the internet, and he was up for having a coffee because we live near each other, and so when chatting to him, he of course realizes my background in climate science, and he was like, you know, I've got a family member who's in denial about climate change. And it's really annoying because, like, I know that the climate scientists are basically almost unanimous about the fact that climate change is man-made. But even knowing this, it's really frustrating that I can't seem to adequately counter this family member.
Yeah.
So I felt his frustration, and I tried to give him, because obviously he's not, a man who's got a science degree, the sort of some of the basic knowledge that you can then use to maybe push back a little on some of these claims. And in the process of that, he was like, "You know what, Mark? You should be doing a podcast on this with your old friend John Rainier, and so that more people can hear it." So, and I thought that was a reasonable idea. So I got in touch with you through a mutual friend, and to my delight, you were up for doing this, and so here we are.
Yeah, awesome. Here we are. So, how do you envisage this podcast going then, Mark? What are your plans for it?
Yeah. So first of all, John, I can't quite remember. What did you study at A-level and university?
Well, I did 2 history degrees. Hang on a minute. No, I didn't. What the fuck am I talking about? Right, let's try that again. That one we can keep in. So I did a degree in medieval and modern history at University at Birmingham. My A-levels were in history and ancient history. That's where I did the 2 histories. Yeah, you can tell it's been a long time since I've been at school. And then I did computer science as well. That's what I studied.
Okay, so a lot of history, and then this sort of oddball computer science thrown in. Okay, right. So essentially, how I see this podcast, just in my mind's eye at this point in time, is that the core of it is that you, John, standing in perhaps for members of the general public who don't know a lot about climate science, who may not have a science degree, so you might put to me various common or not so common denialist type arguments about climate change. So, for example, the climate has always changed. So isn't climate change that we're experiencing now natural? That sort of thing.
And then spoiler alert for future episodes there. Yeah.
Yes. Well, we'll definitely be doing that before too long. So then hopefully I can explain to you, a layperson, why these arguments are problematic. And hopefully we can have a lot of fun along the way and learn a lot about this life support system we have, the living Earth in the vacuum of space.
Yeah, absolutely. I'm definitely looking forward to finding out more about the science behind it. Especially like as I've experienced in my travels, just seeing what a big impact it's having across the world, and that in England it almost feels like all that's happening for us is we're getting a bit more rain. We've had such a wet August so far. I've come back from Seattle straight into some miserable rain for weeks on end.
Right. Yes, it's not been great recently, weather-wise. Yeah. So I guess the other thing, so these arguments, like we can of course, find them ourselves, but like we do encourage anyone who's heard examples within their friends and family of climate denial. If you feel like you want us to respond to them, then by all means, please send us an email, and we'll do our best to cover them. And I guess we'll also express our own opinions on the subject of climate change from time to time.
No, surely not. Surely not. We must be completely objective at all times. Not remotely suggest what we think or feel about this.
But we're humans, John. We have feelings. We can't.
I try not to be. Okay. All right.
Really. All right. But yeah, we'll when we do express our opinions, we'll highlight them as such. So we won't be trying to pass off our own opinions as objective facts.
Yes.
But,
or not alternative facts either. There won't be any alternative facts in this.
No. Not whatever we do, we will not be giving alternative facts. So what about you, John? What were your plans for the podcast? I remember you saying something about a good news climate story. What's the thinking there?
Yeah, well, I think the general discourse, the general kind of discussion around climate change is very doom and gloom, and there's this sense of just being resigned to the fact that, well, climate change is going to happen, and all of this kind of climate doom in some ways is becoming the new climate denial. It's been weaponized as a way of kind of pushing for people to not do anything about climate change. So my intention really is to try and dig through all of that and find some of the positive climate change stories that are out there. What's been going on that's actually like really kind of moving things in the right direction and showing that there is some positivity out there. Not peddling this great phrase you shared with me earlier, not peddling in hopium, but actually showing things as they are.
Right. Okay. Yeah. I guess that's important because we want to highlight the positives, but it is a heavy subject, so we're not going to underplay that, but hopefully we can provide a positive spin on it.
Yeah. Try and sift through and find some of the comedy gold that exists in the topic of climate change. So as well, we've been talking a little bit about how we would like to do this podcast. We're thinking that this is probably going to be like a limited series of maybe about 10 episodes, and then there'll be a bit of a gap before we release future episodes and things like that. And we'll provide at the end of this podcast where you can follow us on social media and things like that, and an email for a mailing list. So in our last recording, before we came up with this new improved version, we went on about politics, but we don't really want to kind of go into too much depth about that. To sum it up, really, we're both kind of on the left of the political spectrum, Mark being a little bit more centrist than I am. But we're going to try our very best to be objective, to show things as they actually are, and leave them open to interpretation depending on people's individual political views, and to try and kind of give any balance. If any listeners feel that that we're not being more objective, we're more than happy for people to kind of to get involved in the discussions and kind of show how we can be more objective and more neutral in our approach with this podcast.
Right, let's get started on our first main climate skeptic argument then. So we've named this podcast the Countering Climate Skepticism pod. Bit of a mouthful, try and say that 10 times quickly. So first of all, just to kind of ease us in a bit, Mark, what do we mean by the term climate? Particularly in relation maybe towards weather, climate and weather.
Yeah, it's a very good question, and fundamental to what we're going to be discussing. I mean, like the bog standard climate denial argument, or the most traditional one, I guess, is that the Earth is warming. We all agree that there is warming going on, but this warming is natural. The climate has changed before, therefore the change that we see at the moment is natural. So from that, you can sort of see that when they're talking about climate, they're talking about they're largely talking about the Earth's average temperature. Yeah. So the Earth, obviously, if you're at the equator, it's warmer than at the poles. But as a sort of rough figure, if you take the average temperature of the Earth, I believe it's about 15 degrees.
Okay.
So if you take a geographical average.
Are we talking centigrade or Fahrenheit there?
Good question. Yeah, it's and I've made a point to write everything in both, so that if American listeners are listening, then they won't be like, well, what the heck is that? So what? Hang on, I have it written down somewhere. Can I quickly find it?
Is it about 50 or something like that?
So it's. I think it was from memory. It was 59 degrees Fahrenheit.
Okay.
Yes, 59 degrees Fahrenheit, 15 degrees centigrade. So comfortable temperature on average, but obviously that's not going to be the case at the poles, and it's going to be much warmer at the equator. So when you're talking about weather, you tend to be on a geographic scale talking about something that's more local. So you talk about the weather over the UK. So you're not talking about the weather over the Earth. So there's a sort of scale difference. Yeah. This average temperature of 15 degrees, we've managed to, over the course of 150 years. So we often talk about climate change with respect to the pre-industrial period. So before we started burning large amounts of fossil fuels, coal, oil and gas. And sometimes they use the year 1850 as the benchmark for that. And so in 1850, global temperatures 14 degrees. In 2023, we have, with climate change, we have raised the average temperature of the Earth by 1.1 degrees centigrade or 2 degrees Fahrenheit. And this, at first glance, people can think this is not a lot. Like if the temperature, in winter in the UK were 1 degree warmer, that would be fantastic. It still gets pretty cold here, but on a global scale, this is something completely different. Your idea, if you're thinking weather and you're thinking a 1 degree temperature change, because we're talking about a sort of a global average, 1 degree is huge. It's a lot more heat in the system, and it has a very large impact on extremes as well, which I'll go into maybe later in the series. But yeah, so as well as it being about in a geographical sense, it's a sort of a larger average. Climate is also in a kind of temporal sense, it's a larger average as well. So typically they might talk about the climate as being the average temperature over a 30-year period. So we're not talking about weather. Again, we're talking about 7 days or, yesterday or tomorrow. So very short periods of time. You might say that the temperature will increase 5 degrees tomorrow or something like that. With climate, if the Earth's average temperature was 14 degrees back in the pre-industrial, having changed to 15 degrees is a large jump. And that 14 degrees would be a 30-year average over time as well as over the... So basically, climate is kind of like weather, but it's over a larger spatial scale and over a larger time scale. So it doesn't tend to change that much, because it's, a large time average and a large spatial average. So having moved it 1.1 degrees so far, that's a big deal. So that's climate. I guess also, there's a tendency to maybe concentrate a lot on temperature, but there's also precipitation, so how much it rains. And the two things are linked because the hotter the Earth becomes, the more water vapor the atmosphere can hold. And so climate change can affect where rainfall falls, how much falls, and how dry the land gets, because as you get warmer, water can evaporate from the ground, and this can lead to droughts in some places and then floods in other places. So this is
that explains that common thing that people often criticize, people talking about climate change when they're saying, well, you're saying that there's this climate change making everything hotter, but it's rained loads here. I guess that goes some way towards explaining that then.
No, in general, the people will typically say, climate change, it's snowing here, wherever I am on the planet. And it's just and people lap that up, it can't be, global warming can't be happening, but then typically if you look at a map that spans the whole globe, you'll get isolated places where it's gotten cooler this year, but the rest of the globe is, red in terms of temperature rise. So you even in an era of climate change, you can still get cold records being broken. It's just that more hot, extreme heat records are being broken.
And that's something that we've definitely experienced over the last 6 months, as we've been traveling across the US. We narrowly missed out the shifting tornadoes across the Midwest.
Right.
There were some wildfires in New Mexico when we were there. But then also California has had unprecedented levels of destruction to the national parks and along the coastline. There are some sections of the Pacific coast that have completely collapsed and eroded away because of record-breaking storms. Up in the Sierra Nevada mountains as well, record levels of snowfall has meant that some of the parks were closed like months longer than they had done in previous years. So it's really noticeable when you're visiting some of these places.
Yes. I mean, were you in danger from any of these wildfires or?
No, we were quite lucky. It was one of those things where it was like everywhere we'd been, we just missed them. We did drive past one when we were in New Mexico. There was one wildfire that we drove past. We could see it from the other side of the mountain range. It looked like this 300-foot plume of smoke up in the air. And as we drove round the mountain, we drove right past it on the road. It did seem like they'd managed to have it relatively contained, and obviously out in the desert, wildfires can occur, but it's the frequency with which they're occurring that seems to be the big change occurring at the moment.
There's a lot in the news right now about the insane heat waves going on in America particularly. I mean, maybe all over the world, I think, but I guess because we're in Britain, we have a lot of we have a special interest, I guess, in what's going on in the US. But I guess on top of there's a phenomenon happening this year, which is called El Nino, which is something that happens in the equatorial Pacific Ocean. But without going into too much detail about El Nino, it means that when there's an El Nino, global temperatures will be hotter than they otherwise would have been. And so this is like a natural thing. It sometimes happens that there's an El Nino and the temperature is hotter on Earth than it would have been. Sometimes it's the opposite, La Nina, which is the opposite phase, and we have cooler global temperatures. But the problem is that we've already raised the average temperature, and then on top of that, you have El Nino pushing it even higher. So if there is no El Nino next year, then chances are next year will be cooler. But
would I be right? They tend to be on like a 4-year cycle, is it? Or?
So it's not as predictable as that. There's kind of a bit of randomness in the system. Like you can't really predict. You can predict to some degree, maybe like a couple of. I'm not entirely sure about this, but there is some predictability when you get fairly close. And people that you see on Twitter, like people guessing, is it going to be an El Nino? Like nerds, like watching. Sorry to all the nerds. Nerds is a cool thing. I got called a nerd on GB News recently. I might put a link in the show notes, but I don't have any problem with nerds and nerding out. So there's a lot of interest in the scientific community about whether the system is going to tip into an El Nino. El Ninos are probably going to mean that there's a lot of suffering, especially on top of the raised temperatures. So anyway.
Okay. So next question then. So what's our definition then of skepticism for this show? What do we mean when we're talking about skepticism, climate denial, or being contrarian?
Yes. Yeah. No. It's a good question, and you get someone come up to you and they say, well, I'm not sure that I know the climate is changing, but is it us that's caused it? I'm not 100% sold on that. And so that person, they could just be, their information sources have made it appear to them like there's climate change maybe is natural. They could be just confused, I guess, or they just don't know enough. But then they could be, under the hood, as it were. They're just not interested. They've decided it's not natural, and whatever you tell them, evidence-wise, it's not really going to change their mind. So I guess you have to watch. So if you give that person the answers to all their questions, the evidence, if then after they come back and their response is, "Wow, I didn't know that. Actually, that's answered a few of my questions," right, I see. If they're like that, then it turns out they've been genuinely skeptical, and they were arguing in good faith. If, on the other hand, they just come up with ever more questions, and keep shifting their arguments, and there's no end in sight, then, as someone who's trying to, educate people about this, it's not worth your time. So I guess you have to, from the outside, it's difficult to tell at first. If after a while you get a sense of whether they're being skeptical or a denier. Piers Corbyn, he's a well-known denier. I would have no problem calling him a denier, because you can see, through history, he keeps on spouting the same rubbish, and there's very little doubt there. Yeah, it's not always obvious. So contrarian. I guess all of these terms are a little bit imperfect. I know some people sometimes have a problem with denier. They get really offended by it because it's got this association with Holocaust denier. But I mean, but the thing is that even if you talk to Piers Corbyn and you ask him, how would you describe yourself? He would say, I'm a climate skeptic, because skepticism is sort of seen as, a kind of a virtuous characteristic. Scientists are supposed to be
questioning
skeptical.
And
I mean, having not taking things on trust. I mean, we shouldn't take things on trust, right? But the thing is that they've kind of misappropriated that label, because it's fine to be skeptical about climate change, but once someone tells you, the gaps in your knowledge and shows you the evidence, and then you're still not convinced, it's sort of, maybe the referring to yourself as a skeptic just makes you, it's just a positive label that you're applying to yourself, when in fact you're a denier.
Yeah, absolutely.
Yeah, and contrarian, I was a bit struggling about how to characterize this. What did I put? Someone, I mean, we've all met people like this. You have a friend or whatever, and you find them making bizarre arguments, and you don't even know whether they actually believe what it is they're arguing.
Devil's advocate,
Yeah. I also thought, it's got a devil's advocate-y twinge, but I don't know. Sometimes maybe they feel it makes them look smart, or they can get attention that way. So they're not particularly wedded to what they believe, I guess, but they just like being contrarian, I guess. For a contrarian argument, there is an argument that says climate change is happening, humans may be the cause, but I reckon the benefits will outweigh the disadvantages. So, for example, in the UK, we've now got a very active vineyard industry. Whereas before, France could grow grapes, we couldn't. But now we can grow grapes, and this is good for the UK economy. And all over the world, there are positives towards climate change. People find themselves, lucky winners in certain regards. But this is a bit of a contrarian. I see this as a bit of a contrarian argument, because we don't think that overall the benefits are going to outweigh the costs, especially as we keep on getting warmer. That argument becomes harder and less tenable. Right, so there's something I'd like to introduce here, and I'll probably keep referring back to it. And it's a way that I found for me to sort of, I guess, classify when someone's skeptical about climate change. In order to be able to be convincing to them, I need to sort of understand their particular skepticism, or what angle are they taking. Okay. For example, I once met an old teacher of mine from university, and it was not related to my climate studies, but they were of the opinion that there are 8 billion people on Earth at the moment, but even so, the atmosphere is huge. How can we, who are tiny, influence something as large as the Earth?
Yeah.
So that's another skeptical argument someone could bring. But it's a little bit different to the other arguments that I've already mentioned, and so the way that you'd respond to that would be different to the way you'd respond to other types of denial. So the ziggurat. So to just explain what a ziggurat is, in case, do you know what a ziggurat is, just off the top of your head? Or?
Yeah, is it like a stepped pyramid? Is it?
Yeah. That's a really good way of describing what it is. So instead of it being like a pyramid, like the or a 2D version of the pyramids of Egypt, it sort of goes up in steps.
Okay.
But otherwise, it's a sort of a pyramid. So this climate skepticism ziggurat that I'm going to talk about now, it has 6 levels.
Okay.
Levels 1, 2, 3, 4, 5, and 6. It goes like so. The first level of the ziggurat is 1. Climate is not changing at all.
Okay.
It's remained the same. 2, moving on to the second level. But if climate is changing, then humans are not responsible for that change. It's natural. But if they are, third level, the amount of change will be insignificant.
Okay.
But if it isn't, level 4, the positives will outweigh the benefits.
Okay.
But if they don't, level 5, technology will come and save us. So we don't need to do anything.
Right.
And then as you go on to the final level, there's a little bit of a bifurcation, which is something that there's 2 ways you can kind of go from here. So the 6A and 6B. So for 6A, but if technology won't solve the problem, then we shouldn't crash the economy to save the planet.
Okay.
That's 6A. 6B, but if technology doesn't save us, then we're doomed, and we should all just give up.
Right. Yeah. So it really neatly puts together, how these arguments build up, and it's really interesting to hear that. And essentially, like you can see how you can, through following that way of thinking, just lead yourself to the point of, so let's just not do anything, rather than actually seeing it as being something that you can actively change and reverse in some way.
Yes. Yeah, and that's very widespread. I guess there is a lot of concern this year, particularly about climate change, because of how hot it is. But one worries that people might sort of gravitate towards that position, because it's a huge problem, and it's one that we are making efforts to address. But it's I guess a lot of people just genuinely feel like, I'm just one individual. What can I do? And there are things you can do. You don't, when we're, a lot of individuals making changes and talking with each other about this and raising awareness, all these things add up, and will hopefully put pressure on politicians and whatnot to get to grips with the problem and give it the seriousness that it needs. But it sounds a bit harsh, sort of, for people who are a bit gloomy about it, to sort of classify them as deniers. And I don't tend to do that, but I guess there is a sense in which doomism can be sort of a type of denial. Because I guess the way I see denial, and the thing that ties all of these things together, right from the very the bottom level, which is like the just flat out denial about the fact that it's getting warmer, which I don't think barely anyone says that anymore, because it's just a bit. No one will take them seriously, because but it was a sort of thing, 10 years ago or 5 years ago, an argument that got put. But yeah. So I guess with the fossil fuel industry has a vested interest in, climate change is a kind of an existential risk for, the producers of oil, coal, and gas.
Yeah.
We can't carry on with business as usual, and climate change is just tremendously awkward for them. And being private companies or whatever, they will private companies respond to shareholders, try to maximize profit. They will try and keep going for as long as possible. Unfortunately, that's just the nature of that sort of beast. But I guess for those who are, there are sort of efforts they're making, but it could be that, like, if they can convince everyone that there's nothing that can be done about climate change, then political pressure will ease on governments, and we can keep on digging up and burning fossil fuels. So they're feeling the heat from activist groups.
Quite
and
literally.
just
yeah,
certainly. So, but yeah, I'm sympathetic to people who are a bit gloomy about the prospects. But I study this thing and have been doing for a decade, and I'm still of the opinion that we can and should do something about it, and there are reasons to be optimistic. So so it's I know it's hard, but yeah, definitely all is not lost. We can do this, Yeah. So I guess the thing that ties all that together, I may have said this already, but the thing that ties all that together is we shouldn't do anything about the problem. So whichever level you can, the sort of the thing that follows from that is we shouldn't do anything about it. So so maybe that's a little bit of an expansive definition of denial, but yeah. So that's what ties everything in the Ziggurat together. Yeah. So I will be talking about the Ziggurat, I guess, going through the series. So I'll maybe put a link in the show notes so people can look at it if they're interested.
Brilliant.
How about you, John? Have you ever encountered climate science denial, or has it not been much of a thing on your radar?
Yeah, no, I mean, like, obviously you see a lot of it in the media. You see a lot of government policies that seem to demonstrate that there may well be some climate-related denial going on, because things seem to be moving in the opposite direction to what supporters of climate change feel we need to be doing. Individually, like I've had a conversation with someone just a couple of years ago who was saying, well, we've been banging on about climate change for 30 years and the world hasn't ended yet, therefore it can't be a problem, and like, it's quite interesting because, like, seeing how that fits into the Ziggurat, you can see where they are on the levels with that. And when we were in Arizona as well a few months ago, we were in the Petrified Forest National Park, and there was a sign, an information sign that was talking about climate change, but talking about it like prehistorically, talking about it from millions of years ago, and was talking about the climate has changed in the last 60 million years. Somebody had graffitied on the sign, like next to it, like, see, climate change is nothing new. And so
clever.
Yeah. And I was right out in the desert, right in the middle of nowhere, and just if I had a pen on me, I would have scrawled all over it, going, "That's happened over millions of years, you idiot, not over 50." So those are the kind of things that I've come across.
Right. Yeah. No, that's interesting. And you're dead right. Climate has changed before on longer timescales. And we'll definitely unpack that a little bit more. But yeah, it's frustrating. Like can we just not like face the problem that we have and solve it? Like why does all of this come out of the woodwork? But it does. That's the world we live in.
Okay, so I guess we'll move on next to the main part of our episode today, of really trying to unpick one of the kind of skeptic arguments, the main skeptic arguments. So this one's related, Mark, to the atmosphere. So my understanding, what is it that the atmosphere is mostly made up of?
So nitrogen and oxygen. Right. So the nitrogen is 78%, 4/5 of the atmosphere. We just breathe it in, breathe it out. It just doesn't really do anything. For us at least. And then there's 21% is oxygen, which we need. That takes us up to 99%.
Okay, so this climate skeptic argument then, if less than half of 1% of our atmosphere consists of CO2, the gas that is supposedly responsible for global warming, how is this having such a major impact? How can such a pitiful quantity of CO2 in the atmosphere be enough to warm up the whole planet? Surely that's nonsense.
Well, the person who put that question has slightly overstated the amount, funnily enough, because it's not that it's less than half of 1%, it's less than half of 0.1%. Right. So it's even more pitiful than that. Okay. That the person who posed the question would say. However, surprise, surprise, I don't agree with what they said. There are, I guess in a nutshell, the answer to this is that there are plenty of examples that I could give to you where trace quantities, trace being tiny, meaning tiny, trace quantities of something can have large effects. So the fact that there's, like nitrogen and oxygen are so much more common in the atmosphere than CO2. Excuse me, the beer is repeating on me. Is not really a good argument. So there's something that so there's something called logical fallacies. Have you yeah, I imagine I don't quite know how common it is to know about logical fallacies, but there's one logical fallacy that's called the non sequitur logical fallacy. Okay. So someone will say, because of A, therefore B.
Right.
And and you listen to that and it sort of sounds convincing, but hang on, does B really follow from A? It's not necessarily the case. So for example, here's an example of a non sequitur logical fallacy.
Okay.
Because people quite frequently, in fact, get injured while doing sport.
Yeah.
That's A. Therefore, no one should ever do sport again.
Yes. Yeah.
So A is true, but can you really say that means B?
Yeah.
So that's the idea behind a non sequitur logical fallacy. A does not necessarily imply B. So it's even less. So carbon dioxide is less than 0.1%, less than half of 0.1%. It's technically 0.042%.
Okay.
So that seems quite small. But so just a quick note here: we don't tend to talk about carbon dioxide in terms of percentages.
Right.
We tend to use a unit called ppm, and ppm stands for parts per million.
Okay. Right.
So if you have a million parts, a million atoms of gas, molecules of gas in the atmosphere, if you have 1 ppm, 1 in a million is whatever you're saying.
Yeah.
So the two numbers with regard to carbon dioxide that are useful to remember are 280 parts per million.
Okay.
And 420 parts per million.
Yeah.
So 280 is the amount of carbon dioxide that was in the atmosphere around 1850, before the Industrial Revolution happened, before we discovered, wow, these fossil fuels, they sure have a lot of energy inside them.
Right.
So 280 parts per million. So that's, even less than we have now. Since then, we've burnt a fuck ton of coal, oil and gas, like just enormous quantities of it. And, and through time, this amount has gone up. And we've basically multiplied the amount of carbon dioxide that was in the air before the Industrial Revolution by half.
Right.
Sorry, so to be clear, we've increased it by 50%.
Yeah.
So we haven't doubled it yet, but we've increased it by 50%. So we've gone from 280 to 420.
Right.
So that is significant, and that has resulted in a 1.1 degree change in Earth's average temperature, and changes to precipitation patterns, etc., etc. Other things that you may know that have tiny concentrations but have pretty large effects. So, do you drink coffee John?
Yeah.
So the amount of caffeine in your mug of coffee is around 400 parts per million.
Right. Wow.
And yeah, but I mean, do you just? I mean, I suppose because we're all so bloody used to coffee, we chuck it down. And it doesn't make a shred of difference, but I guess we still drink it, so we're not. It wakes you up in the morning, or
considering such a tiny fraction, it's crazy that it does that.
Yes, and then the other one. This is slightly more. Have I got the? Yes, great. Okay, so alcohol. If you have a blood alcohol of 500 parts per million, so that's slightly more than the amount of carbon dioxide we have, according to this American Addiction Center.org, you have, it's alcohol.org, the website, but at 500 ppm, at this level of blood alcohol, your behavior will become exaggerated. Right. You may speak louder and gesture more. You may also begin to lose control of small muscles, like the ability to focus your eyes. So vision will become blurry. So small amount of stuff can really have a big impact.
Yeah.
And so there are a few other amusing examples. Like, okay, so John, I've got a cup of tea for you. In it, I've included just 1 ppm, part per million of arsenic.
Okay.
Can I interest you in this cup of tea? It's a very
not inviting you over as a guest, to be honest, Mark.
All right, okay. Sorry. Yeah, I know, you probably won't now. You'll always be like, you made that like weird comment about arsenic and tea. Like, fuck that. It's, maybe being it sort of like 2-3 hours drive from each other. Maybe that's the safest way to be.
So what's the impact of? Was it one part per million of arsenic?
Well, to be honest, I don't know. But what I do know is that the safe limit for arsenic is 0.01 ppm of arsenic in your water.
Okay.
And so essentially, if you have 100 times that, you're literally getting 100 times the safe recommended dose of arsenic.
Yeah.
So I wouldn't touch that tea with a barge pole unless you want to end up like Litvinenko or, poor guy. Wasn't arsenic, it was something equally bad or worse. But yeah, just on the alcohol thing, when you get to 1,500 ppm, so that's like 3 to 4 times the amount of CO2 that we have. This blood alcohol is very high. You will have much less control over your balance and voluntary muscles, so walking and talking are difficult. You may fall and hurt yourself. You get up to 3,000... Have you been there?
Yes, on many an occasion.
Yeah, I'm starting to wonder now. What is my ppm? Having this Corona is half finished, and I'm not. I don't usually drink. So, but yeah. So when you get to 3,000 ppm, so that's like 6 or 7 times the CO2. At this point, you may be unconscious, and your potential for death increases.
Right.
And then it goes up to 4,000, and it's like you're unlikely to be alive at this point.
Okay.
So basically at 0.4%. So that was what your original statement of the question was, right? Less than half of 1%.
Yeah.
In the case of alcohol, less than half of 1% will kill you.
Yeah.
Unless, I don't know, you're made of something special. But this is a more visual one. So it only takes a few parts per million of blue dye to make a bucket full of clear water extremely blue.
Right.
So there's plenty of examples I've given you. I've given you 4 examples of why a pitiful concentration of something does not mean...
Yeah.
So the science of climate science and the history of it goes back a long way. And I think it was in 1856 that a female scientist called Eunice Foote figured out that carbon dioxide is a heat trapping gas,
right.
And if we were to increase atmospheric concentrations, we would likely see a warming of the climate.
Right.
So this is in 1856, and then there was more work done in 1859. It's been 150 years since then, and like we have the science on carbon dioxide and its thermal properties, its heat trapping properties, pretty much down to a T. So we're pretty sure about this 150 years plus later. And essentially, so like I mentioned that the Earth, before the Industrial Revolution, before we discovered the wonders of fossil fuels, because they were wondrous. They power our civilization. And many good things have come from them. But before we started burning them in 1850, we had 280 parts per million. Now we've got 420. Then we had 280. If someone had like a Hoover that could suck up all of the carbon dioxide from the atmosphere, so take out that 280 parts per million bit, Earth's temperature would fall to minus 15 degrees.
Wow. So that's the average temperature for the Earth.
The average temperature of the Earth.
So that really highlights just how fragile it is, and how these tiny changes can make such a massive difference.
Yeah, definitely. And sorry, just for the American listeners, minus 15 degrees centigrade is 5 degrees Fahrenheit. Somehow that's still positive. Fahrenheit is a bit of a mystery to me. But
I spent 6 months over there and it still was absolute nonsense by the time we left. Couldn't work it out at all. All we could work out is above 100 is really fucking hot.
And I don't know, what does naught mean? It'd be something like minus 18. It's like at the point where like even the hardiest of folk need to put on a jumper or something. I don't know. Maybe someone can like write in and explain what's the significance of naught Fahrenheit. Because I'm too lazy to Google it, apparently. So it's kind of interesting. So like the Earth, we're used to the Earth being in the kind of the Goldilocks zone of the solar system. Like we're at the right distance to have like liquid water, because liquid water is very important for like the development of life. But essentially, if you take all the carbon dioxide out, so just have the same atmosphere, just take out all the warming gases like carbon dioxide, which are known as greenhouse gases. Carbon dioxide isn't the only one, but it's the biggest one. Then the Earth is basically too far away from the sun,
right,
to be in the Goldilocks zone. If it was minus 15 degrees, it would be there would be no liquid water on Earth. Everything would be frozen, solid. So we're thankful for having that 0.028% carbon dioxide in our atmosphere. So it's quite amazing, and that enables the nice climate that we have that is supportive to us. And just as a sort of side note, do you know the planets before the Earth in the solar system?
As in closest to the sun.
Mm.
Yeah, so Mercury and Venus.
Yeah, correct. And which one's the closest? Do you know
Mercury.
The two? Yeah. So Mercury, I was looking this up the other day. Mercury's average temperature is 67 degrees.
Wow.
Which was not as much as I thought it would be, actually. This was a Wikipedia check, so I hope the Wikipedia article is kosher there. So this is 153 degrees Fahrenheit, right, for the American listeners. Venus, on the other hand, further away.
Hotter.
Yeah, it's even hotter. It's 464 degrees on average. Yeah, a lot hotter. That's 867 degrees Fahrenheit.
Wow.
So verging on 1,000 degrees Fahrenheit. And the reason for that is its atmosphere is thick, and it's 96.5% carbon dioxide.
Right. Okay.
So heat that gets into Venus doesn't really get out because it has such a thick atmosphere.
Wow.
So this is a sort of like a tangent. It's not really. It's a sort of separate argument. in a kind of a way, because we, even if carbon dioxide levels rise and rise and rise, you and I are not going to have a problem breathing. Okay, so I'll say that at the outset. Well, there are arguments that so we're at 420 parts per million now. If it rises to something like 700 parts per million, which would be pretty calamitous in and of itself, but there will be effects on human cognition.
Okay.
So we will, so quite often, like, we live in poorly ventilated rooms, and because of that, with the carbon dioxide we're breathing out, carbon dioxide levels can rise and rise, and that can make us, that's why, you probably noticed in classrooms, you might, like when you open the windows, maybe like, get a breath of fresh air, and maybe like people perk up a little bit.
Yeah, it wakes the kids up a bit,
Yeah, so carbon dioxide at higher levels, makes us sluggish and sleepy. And so, that's not great, but basically we're not going to struggle to breathe or anything. But there's this great video on YouTube, it's actually like a 3-part. The first part is called "I Sealed Myself in a Jar."
Okay.
And it's this dude who like builds this kind of cube that's maybe about 3 meters high by 3 meters wide, and it's like he builds the frame and then he sticks some plastic tarpaulin over it, and then in the inside he has like devices to measure the amount of carbon dioxide in the atmosphere, and he stays there for, I don't know, like 24 hours or whatever. And he just documents, like, at this level of carbon dioxide, this is what I'm feeling like. And he gets up to 1% carbon dioxide, which is 10,000 parts per million.
Yeah.
And that's the point at which he pulls the plug, because you start to get disorientated. And
did he have someone to let him out? Because this experiment could have gone disastrously wrong.
He did. He did it really. It's like he properly set it up, and he had like a health expert outside, and he also had like a Stanley knife, I believe, that he could, like, if something went wrong, he could just cut himself out.
Okay.
But it's
all in the name of science.
Exactly. Yes. And I think his big thing is, we want to be more careful about ventilating the spaces where, enclosed spaces, because, it's not the same as climate change, because it's just, your local air, but but essentially, and so like there's an offshoot for that video that goes to another channel where a guy starts talking about the physiology of it, and it looks like by the time you get to a concentration of 5% CO2, you're at risk of dying.
Right.
So, that's still, the oxygen level could be 16%. Carbon dioxide has shot up to 5%. You'd think that would be breathable, but no, it's problematic for your body, because carbon dioxide, when it dissolves in liquid, makes that liquid more acidic.
Right.
Just lightly acidic, and, your blood has a certain pH, a certain degree of acidity. And if it moves substantially from that, you get problems. And so by the time you get to 5% CO2, you're in trouble. So this guy bailed at 1% CO2.
Yeah.
But yeah, so we're not. So what's it? 5% CO2 would be 50,000 parts per million. And I've not seen anyone talking about, not even like 10,000 parts per million. So we're not going there, but there is the argument that, we could become thicker globally. Just not, we have a difficult problem. What do we need? We should become thicker. Yeah, it just doesn't. But yeah. So and also of interest. Do you remember like a few years back, like a bunch of Thai kids? No, was it Thailand?
Got trapped in the cave. Those ones.
Yeah. And then Elon Musk called someone a pedo.
Yeah.
Yes. So there's a great film about that whole incident, but the one of the things that was interesting is they're trapped inside this cave, the Thai kids, and people are trying to get them out desperately. But the thing is that as they're in an enclosed space, with every breath they take, they're taking oxygen and they're converting it into carbon dioxide. So oxygen levels are falling, carbon dioxide levels are rising, And I think it's the case that the thing that people were most worried about was that they were going to asphyxiate on their own carbon dioxide rather than oxygen running out.
Right.
So like even at, 5% is not a large percentage, but yeah, it will definitely kill you.
Yeah.
So basically, John, I don't agree with the skeptic's point here. I hope that is compelling. Is it at all compelling?
Yeah, no, absolutely. So, just to recap here, because I've learned a tremendous amount here. So we've disproven here that having less than half of 0.1% of CO2 in the atmosphere can be ignored, that it actually has a significant impact, even though it's a very, very small percentage of the atmosphere. This has been really interesting, Mark. I've learned huge amounts from everything about the Ziggurat of climate skepticism through to what we just talked about there. But before we head off, is there anything else that you want to add at all?
Yeah, one thing that I was so like people quite often, like they say, I don't know about climate science, but I kind of want to quickly kind of become sort of knowledgeable. Yeah. And there's a very, very good channel on YouTube called Kurzgesagt. It's got a German name. Kurz is short, Gesagt, so it's kind of like said shortly.
Yeah.
And Kurzgesagt they're brilliant. Their videos are brilliant. I love them. But they've got 7 videos on climate change, and they're animated beautifully, and they're about 10 minutes long.
All right.
And so I can put a list of these 7 videos about climate change in the show notes. So if people want to go and watch them, but that'll be an hour of your life. If you were to watch these, you will know a lot of the complexities around not necessarily the science so much, but just like, what are we doing? Like, what can we do? What options are there, and that sort of thing. So that's a kind of a good one-stop shop for people who want to clue themselves up a bit. I think that's about it, I guess.
Awesome. Well, I guess now it's time for our good news story. I mentioned at the beginning of the episode that I wanted to make sure that we kind of kept bringing things back to the positives about climate change as well, and what is going on. And one thing that I've managed to find this week, last year in 2022, we passed the $1 trillion mark for spending worldwide on carbon-free energy. So what that means is, for the first time in history, we have spent just as much on clean energy as we did on fossil fuels. So we really are at this tipping point now when it comes to where we put our spending. It's almost like we're entering into a new industrial age of clean energy. By 2024, renewables are going to supply a quarter of US electricity, with it aiming to be 80 to 90% by 2030. So we are at that point where we're turning this massive ship around and starting to head in the right direction. We've just got to keep going with that and not take those steps backwards.
That's great to hear. I didn't know about that particular statistic. That's definitely lifted my spirits.
Okay, so to wrap things up, to any of you listeners at home, thank you very much for tuning in and listening to us today. We're hoping to be back this time next week, where we are going to be returning to the theory that Mark was talking about the climate denial ziggurat. We're going to be looking at the very first level of that ziggurat, the argument that, the Earth hasn't warmed. All right. So we look forward to you joining us next week. If you'd like to contact us in the meantime, then by all means contact us through our email address. Mark, what's our email address again?
Oh, shit. What is it? I've got it written down. It's ccspod280 @gmail.com.
Brilliant. So that's referencing the 280 parts per million for carbon back in the 1850s, is it?
Yeah.
To support the show, do please visit our website on ccspod.podbean.com. That's ccspod.podbean.com. On the website, you can find our show notes and any other things related to the show, any of the resources that we've been talking about through the episodes as well. Also, we'd really appreciate it if you could spend a few minutes sending us a review. Good ones or bad ones are very welcome. We're very new to this, so we're welcome to any feedback and advice on how we can improve. If you've got suggestions for future episodes as well, then do let us know. So that's thank you very much from me, John.
And thanks very much for listening to us to the end, for those of you who are still here.
Excellent. And we look forward to seeing you next week.